All right, so this is 533. We left off at this point last class. I know that was before Christmas break, but I kind of guess maybe what I'll do is I'll go back and remind you what we're talking about. We're talking about comments. Okay, we talked about single line comments, multi-line comments, and documentation comments. Okay, and each are right there. We had a little quiz. We passed that. And what do we do down here? We changed a few things. It looks like we already accomplished that, but now we're in 533. So preconditions and post conditions are covered on the APCSA exam. Okay, pre and post. Okay, pre meaning before and post meaning after. Says software validity testing and use case diagrams, which are discussed in this subsection, are not covered on the APCSA exam, but they are described here because they use preconditions and postconditions that are used by professional programmers. Okay. Determining the preconditions and postconditions help us to test our code and determine the validity of our software. What does it mean to be valid? Right? Says software validity tests. Software validity tests whether the software does what it's supposed to do before it's released. Okay. I remember one of my first job offers, like a real job, was in quality assurance. And basically, it's a good start for beginner programmers. It's where all the high tech, awesome programmers, the ones that have had a ton of experience, will build something and then you try to break it. Okay, so someone could create a game, and you're then the video game tester, aka the quality assurance person that tries to break it and mess it up. But then when you break it, you have to explain what you did, and then you have to offer a potential solution. And your potential solution could be entirely wrong. And in most cases, if you're telling an expert programmer what to do, sometimes it doesn't even go over very well. But if you're like, hey, I broke this, like this is what you're supposed to do, they might offer it with, like, they might accept it and be like, yeah, you're right. Or, yeah, thanks for the suggestion, but I'm going to change it. Thanks for letting me know. I'm going to make this quick fix my way, right? And that's quality assurance. So it says, we should be able to test software before we release it to the customer. So there's different tests, or like the same when you submit a paper, you submit typically a rough draft ahead of time before submitting your final document. It can be embarrassing sometimes if you're making spelling mistakes, or if your customer paid a lot of money for something and you give them something that doesn't work, right? Then there's a huge uproar. Perfect example. There's this camera. I've mentioned this before, and some of you guys know what it is. But there's this video camera system called a VIO, and it's shaped kind of like a triangle. And it has two fisheye cameras, basically like two GoPros facing in two different directions. And it records games, like soccer games, or I think it does basketball. I've used it for futsal. But basically, it just records in these two angles, but it's like it will give you a full 180 degrees. So this one right here is shooting 90 degrees this way, and this one's shooting 90 degrees. And it shoots from these two angles. Then you upload it to your computer, and the software behind the scenes adds both angles in together and tracks the ball, and will automatically, then the camera doesn't move as it's filming, but after the fact, cuts it up where it gives you the final film of it following the ball. So you don't need a cameraman, which is pretty cool, right? Well, they had VO1. When VO2 came out, they said, hey, we're going to also offer live streaming capabilities that it will actually track the ball. You don't have to load it and wait a day to watch it. It will make it happen in real time. It will track the ball with the two cameras, and it all happen. And people can live stream it as well, which is a huge game changer for a lot of smaller teams or high schools that want to film stuff. Well, when it came out, they rushed it because they wanted to hit their original deadline, and they didn't test it well enough. And when VO2 first came out, the live stream function didn't work. And they also didn't tell people that you can't live stream online. You can only live stream through an app that the user has to download. So if I wanted to live stream my Baltimore Kings game, someone would have to download the VO app and watch it on there instead of watching on Facebook or YouTube or some other platform. They didn't tell anyone that. And guess who was pretty upset? People that spent $800 buying the camera and then $3,000 worth of software. It's an $800 camera. And then for every 2 years, if you buy a 2-year subscription, it's $2,999 a year for the software. So I pay for the software. I have VO. I have the software. I pay $2,999 a year for this to track the ball for me. So I don't have to pay someone every single game, hey, can you video this? Can you video this? And it will do it for me. I don't have to worry about it. All I do is set it up, take it down, plug it in, and it's done. So if you were to buy something that expensive that wasn't tested properly, one thing too is like the brightness of the two cameras didn't match up. So when it would turn to this side of the field, it would be super bright. But when it turns to this side of the field, it would be dark. And right at that line right there where the two meet, like whenever the camera, like if the ball is right in the middle of the field, you would see like half the screen is bright and the other half is dark, right? Wouldn't that suck, right? Wouldn't that, you can't spend all that money for that? But they didn't test it well enough. And since then, they've made changes to it. But I never purchased the VO2 because I was in a community of people that were just complaining about this for months, and it wasn't fixed right away. So we do different software tests to make sure those little things don't happen. Hardware tests are something that's wrong with the camera. Software tests is something where maybe it's not tracking the ball properly, which has happened too, where the ball will be on the other side of the field and it'll still be facing this way. And then all of a sudden go, right? Where most of the time it tracks it properly, right? But then all of a sudden it might be looking at a ball that's like 2 fields away, right? So that's another thing I always tell my players. Make sure no other balls are on the field because it might track that ball instead.
Didn't you show us something that you had filmed the VO?
Maybe, yeah. I have filmed a lot. I've filmed thousands of hours of video, and it's all stored in a database somewhere. So I'm also, I guess I'm paying for storage too. So with that, we want to make sure that if we're selling something, because some of you guys, you're just learning programming for fun, but like I learned it so I could sell stuff, right? I could create something, package it up, and give it to a customer and say, here you go, here's what you bought, right? Now I'm going to invoice you for $50,000 for the software that you bought, right? So with that, there's different things that go into testing, and sometimes you can't predict every single possible thing that goes wrong. And all the time, there's software updates. There's updates to the apps that you download all the time. But we want to make sure we don't send something that's awful to our customer. So it says software validity tests whether the software does what it's supposed to do before it's released. This is sometimes very important. For example, if the code is part of a satellite going to outer space or is going to be used for an emergency condition, we want to test it thoroughly to make sure it works and is valid before it is put into use. Over break, I watched Oppenheimer. You guys watched that? You guys seen Oppenheimer? I watched it, right? Couldn't really test that before it actually happened, right? You couldn't test the bomb. Let me see if this bomb works. They spent billions of dollars saving up money to make this thing work, and then they finally tested it, right? What if it didn't work, right? That's difficult. Sometimes you can't predict every single little thing, but there was a part in the movie where they said, hey, we're not sure if this is going to happen or not, but it might just light the atmosphere on fire and basically blow up the whole world, right? Could happen. It's not a 0% chance of happening. It could happen, but probably won't happen, right? Yeah, to test it eventually. And luckily, the test ended up working. Obviously, the ethical side of it, whether or not, that's a whole different question.
Not like
It didn't light the atmosphere on fire. It's just a good thing. It says this is very important, making sure we test everything thoroughly. Good software testers actually try to break the code, right? There'll be times where my kids in summer camp will show me their game and I'll purposely try and break it. Not even tell them. I'll like try to play the game the wrong way. They're like, no, that's not how you're supposed to play it. I'm like, no, like no one ever gave me directions. So then they have to maybe provide a list of instructions before the game begins. If you tell someone, here's a game, ready, play, and you don't give them the instructions, then sometimes you can play it the wrong way. How many of you guys have ever played Clue? You guys ever played Clue before? My wife got Harry Potter Clue for my kids for Christmas, or someone got it for them. I don't remember. But we played it the other day, and I'd never played Clue before. So I had to get the rundown of like how Clue is played, then the Harry Potter version of it. But I asked all these questions, and my kids were like, can we just play? I was like, no, like I want to win this game. If I want to win, then I need to know all the rules. I'm not playing this game to lose, to learn the rules. I'm playing this game to win. And what happened was I won, but I didn't win. Because I said it was this person, this is what they did it with, and this is the right room. And everyone, no one had any problems with it. But then my wife beat me to the accusation room. Need your phone, go. So my wife technically won, but I figured it out first. So she claims she won. But I need to know all the rules because I also like to bend those rules a little bit, right? How Monopoly, sometimes you guys ever play Monopoly and you can like make trades with other people. I'd be like, hey, look, if you give me this, I'll give you dessert, right? And so that way I'm able to get some extra money here, make trades, but it's not against the rules, right? It's in the gray area. I need to know the rules. But with that, we need to make sure to try all the possible conditions and make sure to know all the possible rules that we can know. Sometimes we're not going to know every single little rule or every single thing that can be broken, but it's good to know as much as possible. I'm sure if my wife told you that story, she would tell you she beat me. But I then proceeded to play her in Connect 4, a game that I will beat anyone in this room in. Connect 4 is my sport against my kids. Whenever you lose something, you have to then pick something to beat that person with. Some of you guys might know what that is. If it's like, hey, for me, it's Connect 4. If my kids beat me in something, if kids beat me in Candyland, then I have to go whip them in Connect 4 like 5 times to feel better. All right. You gotta let them know. So always think the preconditions of your code. Think of what they are and see what happens when you break them and see if you can protect or warn against that, right? You never know what users will try to do or what conditions there will be. Try all different types of input. For example, if you're creating a game to guess a secret number and you enter in a letter, the user enters in a letter instead of a number, right? It would break the program. Some of you guys that took Intro to Computer Science with me were like, Mr. Danza, how do I prevent it from entering in a letter? And I said, well, don't worry about that right now. You guys may have created text-based programs in Python and said, like, how do I prevent the user from entering in this? And I said, well, that's beyond the scope of this class or what you're trying to do right now. You can learn it, but we want to make sure that it's functional first, and then we go back and test it. Okay, we want to make sure to warn people ahead of time not to do certain things. For example, my daughter just got contacts over break. Vivian, she's 10 now, and she's been she's worn glasses for a long time, and she's asked, can I get contacts? Can I get contacts? Can I get contacts? I say, why? And she gives me reasons. She thinks she can see better out of them. She'll like them more. But my concern was you won't take care of them. I wear contacts, and I've had contacts since I was 9 years old, right? So I have 25 years worth of experience wearing contacts. Crazy, right? Longer than you guys have been alive and wearing contacts. So for her, I told her, you need to learn how to take care of them. Your eye can get infected. You can get ulcers on the back of your eye. I know a guy that left his contacts in for too long, had ulcers, and now he has like vision problems. problems. How many of you guys wear contacts, right? I have really bad vision. I have contacts. I have glasses as well. But I warned her. I said, hey, look, these are the things that could go wrong. But in the same way that if your parents told you something could go wrong, you might actually have to do it first or hear it from someone else, right? So then I got to the eye doctor appointment, and they taught her how to put her contacts in. I'm sitting there watching her, and the doctor said, hey, you have to make sure to take them out. You could get ulcers. And I said, hey, can you explain to her what ulcers are? I could easily explain it to her, but hearing it from someone else sometimes is different, right? Sometimes your parents tell you something and you might not listen to them because they're your parents, right? Especially when it comes to like driving, right? Or when it comes to life stuff, you might not listen to them and say, yeah, I'm going to do it. Then you might do it on your own and be like, oh, I should have listened to my parents, right? I shouldn't have ate 5. I got, you know what cosmic brownies are? The like brownies, I bought a pack of cosmic brownies. I brought a pack of zebra cakes, and I brought a pack of ho-hos, right? All awesome, right? And you tell your kids, don't eat multiple ones. You might get a stomach ache. And they go and do it, and they eat them. And they're like, I'm never going to eat those again because I got a stomach ache. Okay? So with that, we want to make sure to test things out, all possible conditions ahead of time. And sometimes you might not be able to know these things, and you might have to try and break it yourself. You might not listen to the instructions that were given, but you have to try and predict possible things that could go wrong. In the same way, I've developed my procedures and tried to think of frequently asked questions of things that went wrong in the past. And then once that thing happens, I then realize it and be like, oh, shoot, your Chromebook doesn't have this. I have to put it in FAQs so that way if someone uses it with the Chromebook, they then are warned ahead of time. Or then some people don't even read those things and just do it and mess up either way. So preconditions and post-conditions can also help us design better software systems. Software designers often first draw a high-level use case diagram of a system that shows the different ways a user might interact with a system before they build it. I took a class in college, IS 170, which was all drawing diagrams and writing zero code. It was like draw a diagram and write all the possible use cases of a program that would do A, B, and C. And I really wanted to program it, but I couldn't. I had to draw these diagrams first. And they kind of made you overkill all the diagrams you would draw, right? And you don't have to do this all the time, but it's a good practice. And sometimes if you work in software, this is your job one day, your boss might require it. I was watching, you guys ever see Chicken Run, the claymation? Like it's like stop, what's it called? Stop motion, right? Where they take a picture and they move it forward and they take a picture. I think the new Pinocchio movie was made via stop motion too. If you guys saw that, right? It took 6 years to make this movie. It was Chicken Run, Dawn of the Nugget. It was the name of it. And we watched the movie the other day, and they said it took 6 years. And they had these storyboards that was all the way up to the ceiling, all the way out to like here. And they would basically just like go through each story, but kind of like imagine like a book, right? Like it was laid out like this. And they would just look through these storyboards, and they'd like pull one open and pull the next and the next and the next. And it had like every single shot, thousands of sticky notes, all like laid out. Probably hundreds of thousands of sticky notes, right? Laid out of the way they want things to look like and who's in charge of each cut and who's in charge of this and that. And it was so well planned out, right? Sometimes you might get caught so much in the planning phase that you never execute, and you might not actually even write the program that you set out to write. So it's good to find the right balance to not spend too much time planning. And then also you don't want to jump right into it without any planning. So it's somewhere in the middle. But you create these diagrams to kind of predict what will happen, right? I like this side of computer science because you start to notice patterns in human behavior. And if some of you guys are interested in like artificial intelligence, right, that makes predictions based off of data it collects and then is able to push out a potential solution based off of experience, right? So it says, here's a simple use case diagram of a restaurant system. It shows two actors, a customer and the staff, okay? And three possible use cases. What is a use case? It is a particular user interaction or situation in the system or software that they can become methods in the program. So things that can happen, right? Basically, that's what a use case is, right? A user might do this. A user might do that. In this case, the customer might order food. If the customer orders food, how does that affect the staff? Okay. The customer might eat food. Does that affect the staff? Right? If the customer is sitting there eating a cheeseburger, is that affecting the person that cooked the cheeseburger? They might want to know, like, hey, how's your cheeseburger? Right? But that not necessarily affect them too much. Okay. The customer needs to pay. If the customer doesn't pay, there's a problem. It affects the staff. The staff might say, okay, it's time to pay. What do I need to do? Do I just tell the customer, hey, pay me money? No. You have to tell them how much it costs. There's a process and procedure, right? If the customer says, I'm ready for the check, what does the staff member need to do? Hopefully they were trained to walk on over. They might already have the bill with them, but print out the bill to deliver it to the customer, maybe give the customer some time. What if you give the customer the bill and you just stand there and just wait and just look at them the entire time, right? That might not be proper procedure. Typically, if I know the bill is about to come, I'll have my wallet out, I'll have my card already on the table, so that way they don't have like that awkward moment where they're trying to wait and see. I'll immediately just give them my card to pay for it, so that way they don't have to then come back. Sometimes they might take like 10 minutes to come back, and I don't want to wait 10 minutes, right? I want to pay right there. Okay, so these are possible use cases: order food, eat food, pay. Any other possible use cases, right? What if they maybe water refill? That could be a possible use case, right? I'm assuming we're in like a restaurant here. What says restaurant system? After drawing a use case diagram, designers write down the preconditions and the post conditions for each use case. Pre, before, post, after. Pre-game, post-game. Often the successful post condition for one use case becomes the preconditions for the next use case. For example, order food and eat food are below here. The precondition for order food, the customer must be in the restaurant, and the staff has to be ready to take the order, right? The customer doesn't just walk in the restaurant and scream out what they want. Say, hey, I want 10 wings, right? Someone's gonna be like, all right, who's in charge of delivering this, right? So typically there's a process. Maybe another use case could be like seat the customer, right? The customer needs to walk in. There needs to be an empty table. If all the tables are full, you don't just say, all right, I'm gonna go ahead and just shove you in this table with this family over here. You guys had an open seat. I'm just gonna put you in with this family, right? That wouldn't make sense. Okay. The post condition for order food would be that the customer orders the food and the staff takes the order. So what needs to happen before the customer orders food? Okay, so precondition, they enter the restaurant, the staff is ready. Then they order food. Then what happens? Then what happens? The customer orders the food and the staff takes the order. The precondition would be, okay, to eat food, the customer would have already had to order the food, and the staff had to deliver the food. The post condition, what happens immediately after you run the eat food function or the eat food method? The customer eats the food. If you told the turtle to move forward 50 spaces, right, and you run that method, what happens immediately after? The post condition is that it moves forward 50 spaces. Okay, what are the preconditions and post conditions of the use case pay for food? Okay, so I'll write preconditions. most likely you'd have to be like the customer is done eating the food, that the customer is also ready to pay. Anything else we can think of? Okay. The post condition would be customer pays for the food. This is, yeah, we're just talking about pay for food. Yeah, so typically, like if I'm paying for my food, right? But this might, I mean, this is if you sit down at a restaurant, I'm assuming. It says these are often related to the order food and eat food. So maybe I can even add, like you said, customer has ordered food, customer is done eating food, customer is ready to pay. God bless you. Are any of you guys slow eaters? Like really slow? Yeah. Anyone else? My youngest daughter is the slowest eater known to man. Actually, I take that back. I had a roommate when I played soccer in Atlanta who would probably take like 3 hours to eat his dinner. He would just sit there, he'd put on the TV, he'd sit at the table, which was like really, the TV was probably like as far away as the door, but he'd sit at the dining room table and he'd make food and he'd just sit there and he had food in front of him. I don't know how, like it'd be freezing cold by the time he'd make like a ton of food. And he'd sit there, I'd see him take his fork, put the fork down, stab his like on a chicken, right? And then look at the TV. And then take like a bite, chew it, and not like go back to his food for another like 5 minutes. Like I have no idea how you do that. Like when I get food in front of me, I'm ready to eat. I get it done with. I'm a quick eater. I eat it. I probably eat it too fast, right? I probably should eat slower. But my youngest daughter, she just like she never finishes her food. Never finishes. I'm done like 3 meals and she's still eating the first thing she started. But with that, customer has done eating their food, ready to pay. Okay, I hinted at this. I said, maybe sometimes it's not a good idea to plan everything out ahead of time. Maybe it's good just to plan just enough to get whatever you need to get done that day, and then maybe reassess the next day. And then maybe get that work done that day and then reassess the next day. This is called agile software development. There are different models for software development. Basically, there are different ways to write software, right? Because you're not going to always be working by yourself. Most of the time, if you're working in a company, you're going to be working in a team of people and you're given different tasks. And for some people, it might be your job one day just to break up those tasks. That's my favorite thing. I love being the person that just breaks it up into smaller bite-sized pieces. That's called decomposition, and just deliver that. Hey, you work on this, you work on this, you work on this, you work on this. I'm going to do this, right? So it says the waterfall model, developed in the 1970s, is a step-by-step model where each phase is finished before the next phase begins. Okay? This model has been recently criticized, right? Here's the waterfall model. So first we think of all the requirements. Let's say we're going to write, we're going to make AACS their own app, right? The AACS app, and it's going to be downloadable from the App Store and the Google Play Store for Android users like myself, right? We're gonna have to write it then in Swift, and we're gonna write it in Java. Swift will allow me to write it for iOS devices. Java will let me write it for Android devices. So if you guys learn Java, you guys can write apps for Android devices. You can also learn Kotlin. There's a few other languages that you can use as well. Okay, but think of all the requirements. What are we going to need in this app, right? What do we want this app to do? Okay, Do we want like a single click to email all my students' teachers? Do I want there to be updates on the app? Like if it's snow, which by the way, apparently it's supposed to snow this weekend. Fingers crossed, hoping that it snows. It's supposed to snow 12 inches in Virginia. 14 inches in Virginia. Last year it didn't snow. This year it needs to snow. Let's think of all the requirements of all the possible things. We need an alert to go off and a push notification sent to everyone's phone whenever school gets snowed out. We need to make sure that maybe there's a way. What if I could download the app and on my side, if I know that Josh is sleeping over there, I could just be like, all right, I'm going to send a push notification to his parents and tell him Josh is sleeping in class, right? And click it, right? And it just goes off, right? And sends it. And then immediately, maybe I can send something that sends a push notification to Josh's phone, right? And I just click it and it just goes off, makes a really loud, annoying noise, right? That'd be good, right? Let's think of all the requirements, right? Then let's design it. Let's make sure we do all the pretty side of it. Let's make sure we draw all the pictures. What do we want this app to look like, right? Let's create a new AECS logo to put on there, right? Let's make it all look nice and pretty and draw all these use cases. And I don't know, I can spend like on this whiteboard over here and fill up this entire whiteboard and that whiteboard over there. And then I take pictures of it and then we make changes to it. And then we finally implement it, right? We actually write all the code. We make it look nice, right? We check amongst each other and we say, all right, this looks good. Let's deliver it to Mr. Dirksey. And we deliver it to him. And you know what he says? This is awful. This doesn't do anything I want it to do. I wanted it to do A, B, C, and D, and it didn't do any of those things. Guess what I need to do now?
Redo it.
I need to go all the way back to requirements. And these months of planning are now ruined, right? What if there was a different approach that was more agile, right? This model, the waterfall approach, one step after the other, has been recently criticized because it's not very adaptable, right? The more recent agile development, this is what almost all software companies use. This is what they use in the private sector and the public sector, government funded projects as well. A lot of people use agile development. Okay, this is more iterative and more incremental, and you work in 2 to 3 week sprints. Now, this requires some bit of planning, but the purpose of it is, hey, there are things we're going to accept that, I can't predict the future all the time, right? The customer may have told me I wanted A, B, C, and D, but then I give it to the customer and them say, nah, I didn't want those things. You may have done everything the customer wanted and you give it to them and they just say, I changed my mind. Guess what? That happened to me like 1,000 times, right? And I sit down with the customer and I say, what do you want? And I take all my notes. This is my note-taking journal. Let's see if I have it in here. I may have left it at home. Is it here? I think I felt it. Oh, here we go. Right. I'll take all these notes. I'll sit down with the customer. Right. I'll be all nice with them. I used to not be good at talking to people. I was afraid to say anything throughout the school day, but I'll take like a ton of notes now and I'll talk to them, try to get everything out of them. And then I say, okay, so just to confirm, these are the things that you want. This is what you want it to look like. And they're like, yeah, that's what I want it to look. And I go and make it for them. And guess what? Actually, no, I didn't want that. I didn't want it done that way. I didn't think about that. So that's why we create these use cases of possible things that could happen. We can predict it. And the more that you write software, the more things that could go wrong. So rather than taking months to plan all this out, let's just work in 2 to 3 month sprints. 2 to 3 week sprints, sorry. Short 2 to 3 week sprints. And where we do the entire process, we're able to completely develop, test, and then release something and say, hey, look, here's a checkpoint. What do you think so far? because it may have taken an entire year to develop something and then say all of it's garbage, restart, right? Wouldn't you rather find that out 2 weeks after you started it rather than an entire year after you started it, right? So 2 to 3 week sprints, right? Checkpoints. Okay. What if I didn't give you any direction whatsoever in this class and I said, all right, go ahead and just do this entire CSAwesome stuff by yourself, figure it out, ready, go. And then like now comes around, we're in January, and I say, hey, let me go ahead and see what you've been doing. And if I check and I'm like, oh no, you didn't do this the way I wanted you to do it, right? You didn't run any of the I guess the tests when it asks you to test your software, you just skipped over that portion, right? If I don't have gradual checkups, it's hard to then grade an entire year's project. The same way in your practicum process, there's different checkpoints to hit, right? But someone had to sit down and create those checkpoints for you. That's what I like to do. I like to come up with those checkpoints. Sometimes I'm completely off. And I may have wasted 2 to 3 weeks on a project. But that way, you're at least able to give the customer feedback so they don't wait for a long time. Can you imagine a customer paying you hundreds of thousands of dollars to do something and not responding or not giving them any updates for months? Your parents, too. They pay tens of thousands of dollars for you to come to school here. Can you imagine if I'm your teacher and I don't grade any of your stuff for the entire quarter, and then all of a sudden, just boom, throw in all of your grades at the last second, right? Your parents are like, wait, what? You didn't give me, I need weekly updates, right? I didn't know where my kids stand. I didn't know they were failing the class. I didn't know they didn't turn in all this stuff. It's partially on the student, but then also it's on the teacher as well, right? So can I give you feedback, right? Can I give you things? Can I find a way to give you your feedback as soon as possible? Some of you are smiling because you may have had teachers that don't give you any of your grades right away. I try to do it as soon as possible. I know I'm not always the best with it, but I try to set routines. If I didn't set routines and procedures, then I wouldn't do it. Okay. I need to do that for myself as well. Okay. Agile development. We definitely watched this video at some point. I can't remember when we watched it. Oh. Okay, here's a video. Okay, there you go. You watched it. Basically just said everything that, well, actually, you know, let's see. I'll play it.
Complex projects can lead to real headaches. Organizing the team, changes in scope, roles that aren't clear. But you can change that with Scrum, an agile framework. At its foundation, Scrum can be applied to any project or product development effort. Here's how it works. A product owner creates the product backlog, a prioritized wish list. During sprint planning, the team pulls a chunk from the top of that list and decides how to complete it. The team has a set time frame, the sprint, to complete their work. They meet in a daily scrum to keep the work moving forward. Along the way, the Scrum Master keeps the team focused. At the end of the sprint, the work should be potentially shippable.
The Scrum Master. The Scrum Master doesn't have any other job other than just like keeping people on track. Somebody just stop by and sit down. You might just love people. I'm somewhere in the middle. I'm not. Sometimes I like people. Sometimes I want to be in a corner somewhere away from people, right? But a Scrum Master literally just like is like a hype man. Just keeps you motivated and stops by your desk and be like, all right, what do we got today? How can I help? What can I do to get you on track? It's kind of like your captain, right? That's your Scrum Master.
In a daily scrum to keep the work moving forward. Along the way, the Scrum Master keeps the team focused. At the end of the sprint, the work should be potentially shippable. The team conducts a sprint review on the product and a retrospective on the process. Then, they choose the next chunk of the backlog, and the cycle repeats. With Scrum, you can ensure the most valuable work has been completed by the time the project ends. Tackle your projects with Scrum.
Probably could have picked a better name. I think of Scrub. Scrum.
I'm sure that was just someone's name or something.
Yeah. What's up, Wells?
Scrum.
Do they have an app called Scrum or
I'll look it up. The question was, is there an app called Scrum? It's just like there's agile development, and then so agile is just like the name that someone created for it, and then like Scrum is just a way of doing things. Like it's not a company, it's not anything like that. It's just like, this is a Scrum method. This is a different way of doing it. This is a different way of doing it. And they all fall under the agile, right? So why is it called Scrum? It's an abbreviation. It's an abbreviation for scrummage. It shows a picture of a rugby team, right? Because rugby, they're called scrums, right? Yeah.
It's based on scrimmage, all of that.
Scrum, right? There you go. That's Scrum. So you could be a Scrum master and literally never code. Just walk around and be like, hey, how's it going? How's your day going? What can I do? Oh, I noticed that you like put your head down on your desk and you're sleeping during work. What can I do to help? Like, do you need an energy drink? Need coffee? I can stop by and get you coffee, right? By the way, she needs some help with this. Do you mind helping her with this? Oh yeah, cool. All right. Move on to the next person. And you just go around and just like talk to people all day and make sure they're on track. And just be like, hey, just want to check in with you, see what kind of work you've done recently, right? Which is hard for me because like I'm someone like if I say I'm going to do something, then I typically do it. And if I like give you an assignment to do, I'm also not going to babysit you. To me, that's a little overboard. So like for my company, I don't have a Scrum Master. I give you something to do and you do it. And if you don't do it, I'm not going to sit over you and ask you, hey, do you need a coffee? I'm going to say, hey, you need to find a new job, right? I'm going to be a little different in my approach. Okay, that's just me. Some people are very nice. I'm not always. Working in pairs or groups. So we're going to work on it together. Come up with 4 steps that a user must do to purchase a product. For example, a book on Java in an online store and the list of preconditions and postconditions for each step. So come up with 4 steps. So 1, 2. What's that? Yeah, that's one of them, right? And then I'm also going to list, hold on, preconditions, postconditions. You could pretend to buy something online. You guys want to buy something online? I'm logged into my wife's Amazon account. I should buy her something. Right? Wouldn't that be nice?
New Year's present.
Buy her something that I can also use. Those are the best presents to give. All right, maybe I won't. What's something my wife would want? What's that? A long break from school. We just had one of those. A what? A machine? A running machine. Oh, like a treadmill. Okay. There you go. I love it. Love it. I'm not a big treadmill person. I like running outside, but I see what you mean. All right. So what do we need to do? Corbin, what did you say again? Save up money. I don't have to worry about money because I'm a teacher and teachers make a ton of money. So
I think that's kind of like set up a budget.
Stay in the budget. Okay. So set up a budget. Okay. So save up money, set a budget as well to make sure. Okay, so I think we're good. We have the money. Now we have the money. What do we do?
Find trusted sources to like verify that you'll get what you're getting. Like,
So are we gonna buy it online?
yeah, you can buy it online.
So you're trying, so like see if you actually want the product.
Yeah.
See if the product's worth the money. Okay?
I want to get a
It's not us. Let's say it is worth the money. We're like, this, what's it called? The popular bike thing that people ride? Peloton, right? That's definitely not worth the money for me. It's, what is it, thousands of dollars for that thing? And you guys have a Peloton? No. You know what a Peloton is? It's like a bike where you can like track all the progress and all that. All right, it's worth it. Then what do we do? It's worth it. Now what? I decided I want to buy. What's that? Find a place to buy it. So maybe consider places to buy product. Maybe find compare prices. Because no matter how much money you have, always want things cheaper, right? Always want cheaper gas. But is the quality going to decrease too much, right? Is it going to be a great product or is it going to be a low product, right? Like get something that's comparable. So compare prices, decide purchase location. Let's say we decide to buy from someone on Craigslist. We're like, Craigslist, the best place in the world. I really trust this person that lives in the middle of nowhere, that I can't find this person even exists, but I'm going to trust them. This is the best possible option. It's for like a quarter of the price that I can find anywhere else. I'm going to buy this product, right? I'm going to buy this new car. Okay. Then what do I do? Okay, so we were looking at reviews, right? I think that's part of the is see if the product's worth the money, right? Check reviews. This is we decided we wanted to buy it, right? Then we finally where. So is it worth it? I guess is what I could classify that. And then the next is where do I buy it? Third is okay, how do I pay? Okay, so what do? We make the payment online. Enter my debit card info. Enter my shipping address. Then I wait, right? What am I waiting for? Okay, so when will it arrive? Okay, so finally the product arrives and I can test it and then maybe leave a review or customer support. There's a problem with it. Okay, so I said, is it worth it? You determine, you save up the money, set a budget. Where do I buy it? Consider places. I finally bought it. Then, all right, I finally get my product. It's here. Okay, the preconditions of, what am I finding the preconditions of? List the preconditions and postconditions for each step. Oh man, I think we kind of did that already. I'm just gonna leave that there. I think we dove deep enough into this. Okay, here's a simple class called user. that could be used in an online store. Add good commenting to this code before the class, the instance variables, and the method. Well, let's read through. So I have a class called user. I have my instance variables. This method right here is called my what? It starts with a C.
Class. Method.
My class up here, this is my constructor. Constructor with no parameters. And this is my constructor with 2 parameters. This is a method that welcomes the user. This is my main method. And let's just go back and look. Okay. So in line 1, I'll just say this class accepts 0 or 2 parameters. This is guest login. Just reading through what it's doing. And either creates a default username, and password, or sets a username / password of the user's choice. I'm just reading through this. So I'm looking at it, right? So if you go down the bottom and you have your main method and you create a new user, right? If you don't enter in any parameters, it just takes it and it automatically makes your username guessed and creates a password for you by taking a random number and multiplying it by 1,000 and then casting it as an integer. Right. If you did add it, then it basically sets it says cooldude@gmail.com would be your username, and coolness with a capital C *10 becomes your password. I guess I should run my code. Let's see what happens. It probably just like automatically lets it go. Yeah. Oh.
Oh, it's because we erased the thing at the top.
Is I won't write anything here?
No, it's because like the top thing how it said like comments.
A comment starting with
Like in line 1, that we erased.
put stuff up there.
No, like it said like comments with a question mark at the end. Yeah, I think that's what it
No, it says not having it, so.
What's that?
Because you have 2 comments instead of 1.
It didn't like that I had 2 comments. That's dumb. There you go. Hopefully that will fix it. There you go. So I just created a multi-line comment. Okay, we talked a lot about this. We spent a couple days on it. Completed. Well done. Any questions on this? Not sure how they managed to tie in. Here's how I can imagine this went. All right. We wrote all of these lessons and we forgot to put agile development in here. Where's a good place to squeeze it in? Oh yeah, let's squeeze it in the comments lesson, because that makes no sense to include the 2 in the same lesson, right? It was like, these are comments. Oh, by the way, this is agile development. Okay, cool. What does it test you on? Nothing. It just tests you on the comments again. There's a way to make the lesson longer. Completed. Well done. All right. What time does class end? I will never know. I will ask you every single day for the rest of the school year. I will never know what time class ends. I will never remember. 5.4. Accessors/getters. We're going to work and see how much we can get done. Oh, I see app inventor blocks. Kind of like Thunkable. You guys remember Thunkable?
Yes.
App creation stuff. When I taught Spalding, we use App Inventor. Great thing about App Inventor is it's run by MIT. So like you're able to have similarities to Scratch, that's supported really well with good documentation. The problem with App Inventor was if you're testing it, it would only work on Android devices. So if you create something in App Inventor, it would only run on Android devices. I wonder if that's still true. I like the App Inventor, but then I switched to Thunkable when I got here because at Spalding, everyone had their own. Like I had a cart full of Android tablets, like 100 Android tablets. So everyone would walk in, I just give every single person a tablet, and as they walk out, they just put them back, and I plug them all in at the end of the day. So you'd have a tablet, you could test right on there as you were doing it, which was great. So on my wish list is, I wish I had a bunch of iPads, like an iPad cart, and you'd come in, I give you an iPad. Right? That'd be nice. Anyway, since the instance variables in a class are usually marked as private to the class, if you want code outside the class to be able, hold on, let me make this a little bigger. If you want code outside the class to be able to access the value of an instance variable, you need to write what is formally known as an accessor method. Everyone knows it as a getter, right? Accessor, just a little too fancy. We're going to call it a getter. Basically, it's going to get the variable for us, right? If I were to tell Corbin right now, hey, can you go get me a cup of coffee, right? Right? Corbin would be my getter, right? He would go get it for me, right? It is 12:33. And that's really what a getter does. A getter goes and gets something for you. That's simple. A getter is a public method that takes no arguments and returns the value of the private instance variable, right? So if you use a language like App Inventor, we didn't use App Inventor in APCSP, we used Python. You may have used setter and getter blocks. Josh, what did you use? What do you use at Mead? You used code.org, but was there like a name behind like the blocks and all? Was it like their own proprietary like coding language?
Uh,
You don't remember?
you mean like the kind of
Yeah, you like put a bunch of blocks together. I remember
yeah,
when you first got in here.
yeah, I don't remember what it was called, but I think it was just
Gotcha.
maybe it was just like
Could you transfer it second semester?
yeah.
Okay, cool. That's right.
Mine,
All right.
you just use the variable.
It says if you use language like App Inventor, you cannot make your own classes, but you can declare user interface objects like button 1, button 2, all from the button class, and use their get/set methods for any property like below. We'll talk about setters in the next section. Okay. So some of you guys might remember this. This was similar to Thunkable. It was like set button 1's height to 50. That looks like a Thunkable block.
Or maybe like a scratch block,
Yeah, like a scratch block.
like a custom scratch block. I have not seen those two blocks in the main menus, but I know you can add custom blocks in Scratch.
Yeah. You don't need to write a getter for every instance variable in a class, but you want to write code outside the class to be able to get the value of one of your instance variables. In order to do so, you'll need to write a getter that looks like the following. All right, so I have my class called example template. I have my instance variable called private. My instance variable called type of var, so type of variable. We've marked it as private. And then it says var name. Then what I was able to do, for this guy right here, right?
Oh, okay. You can take care of it. Sorry to interrupt.
No, you're good. You're good. So we have our getter right beneath it. And it says type of var, get var name, and then you're able to return it via that method. It says notice that the getter's return type is the same as the type of the instance variable. Okay, so if it's type of variable, it's a string, int, anything like that. It needs to be the same. And all the body of the getter does is return the value of the variable using a return statement. Okay, so it does one job. It just returns something. We'll talk more about those return statements in 5.6. But for now, just notice that it is followed by an expression whose value must be the same type as the return type in the method's header. Okay. In a getter, that will definitely be true as long as the type of the instance variable and the return type of the getter are the same. Okay, another example. It's going to be easier once we start using these. It says in this example, it's a getter called getName of the student class, which also demonstrates how to call getName and a student object. So I have this class called student. I have an instance variable called name. Okay. I then have a method here called getName, and it returns whatever the name is. Okay, that's how you would access that private instance variable. Now, where will we use this? Here's our main method. We create a new student. And then if we want to print out the student's name, we could do that using the getName function. Okay, so you'll see very frequently set and get used before one of these, and it's just a common way of writing setters and getters. It says note that getters only return the value of the variable. In other words, the code that called the getter and which received that value has no ability to change the object's instance variable. They just get a copy of the value. They cannot change it. However, if the instance variable is a reference type like string or person, the value that is copied is the value of the reference. Okay. So once again, however, if the instance variable is a reference type like string or person, the value that is copied is the value of the reference. That means the caller receives a new copy of the reference that points to the same object as stored in the instance variable. That's pretty verbose and a lot of stuff going on here. Once we start testing it, it will make a little bit more sense. And it keeps on calling. In the next section, when we talk about mutation, you'll see how that means the caller might be able to change the object even though it can't change the reference. Okay. Some common errors when writing and using getters are forgetting a return type like int before the method name, forgetting to use the return keyword to return a value at the end of the method, or forgetting to do something with the value returned from a method like assigning it to a variable or printing it out. Okay, let's see if we can get through these two sections here. Okay, it says try the following code. Note that this active code window has two classes. The main method is in a separate tester or driver class. It does not have access to the private instance variables that the other student class has. Note that when you use multiple classes in an IDE, you usually separate them in separate files. And you give the files the same name as the public class in them. Okay, so let's take a look. So I just talked for a while. Now we look at the code. So I have a class called tester class. I also have a class called student. Okay, where is my main method? My main method is inside tester class. Okay, so let's see how this works. So inside my main method, I'm creating a new student. The student's name is Skylar. Skylar at sky.com is the second argument that's passed in. And the last thing is 1, 2, 3, 4, 5, 6. If I'm just looking at this, I'm assuming that the three arguments that are passed in, I'm assuming the second and third arguments that are passed in are the username and password. And maybe the first is just their first name or what they'd like to be called. Then it says print out name. I'm accessing a getName method inside of S1, which is my student object. And then it says there's a bug. Don't know what the bug is yet. Hey, guys. So here I have an email, and I have s1.email. I already see a little bit of a mistake here. Okay, the parentheses. Also, let's see here. Do I have a get email? I do. I have a get email method down there. So this would be get email, right? Because I have my get email method way down here. See it? So I changed s1.get email. And then ID is get ID. Let's see if that's the same method name. Yeah, get ID. All right, just off a first glance, let's run it. Let's see what's wrong. Okay, it worked. So what did this do? The get name looked at the S1 object. The S1 object comes from the student class. I look inside the student class. I have my instance variables here. I look for the get name method. I look, oh, there's get name. What does get name method do? It returns name. And the name, what was passed in originally, it shows right here in my constructor, my name was the first argument. Now my parameter init name becomes the instance variable name, and it's stored there. And that's what I'm returning in the get name method. The get name method is returned, and now I'm able to get the name. I can access a private instance variable inside of the class by using the get name method. I know that sounds like a lot. If you weren't following along and maybe just vaguely listening, that didn't make sense. But the more we do this, the easier it's going to get. We write getters, and we're going to talk in the next lesson about setters as well, right? You could name this whatever you wanted. You could name it gname, you could name it gemail, gid, but it's just very common to call it get and then whatever it is you're getting, right? Someone that loves simplicity set that standard. I like things being easy as well, right? Things that just make sense. Okay, that's where I'm going to stop. Okay, so 541 is where we'll pick up on next class. And that's all I got.